Good morning, grade 7s. Welcome to your daily mathematics lesson brought to you by WorksheetCloud.com. Hope you guys are really well today and looking forward to getting stuck into some more geometry or space and shape work. A reminder of the email address on your screen, grade7@worksheetcloud.com. Please feel free to use it at any time. Okay, so today we're going to carry on with our transformations theme. We've done reflective symmetry, rotational symmetry, and today we're going to have a look at enlargements. So that's got to do with making shapes bigger or smaller and finding out how we make them bigger. Okay, and on either side of that we've got our warm-ups and challenges just to keep your minds fresh and active. So today's warm-up is to find out the value of that marine life. Don't forget the pink question mark at the end. Press pause and see how you guys get on. Working through that, I'm going to give you the model answer here. I must be honest and say it took me a while to work this one out. I started at the second line and I just used various values that made 10. But eventually what worked out was 5 plus 5, and what threw me there was you would kind of expect the 5 and the 5 to be the same symbol, which it isn't. So it threw us a little bit of a curveball there. The total worked out to be 8. 8 divided by 8 is 1, and then that multiplied by 5 is going to equal 5. Okay, we've done the second line. So then we've got 8 minus 1 plus 5, and that means the fish is going to be equal to 12. And then we've got 12 equals 8 plus 5 minus 1, and then 8 minus 1 plus 5 equals 12. And then for your question mark at the bottom, 8 plus 5 times 12, and by now we should know that we do multiply first, and 5 times 12 is 60, plus the 8 is equal to 68. Okay, so well done if you worked through that, and if you had to start again a few times but you kept going and you got to the final answer of 68, that's a good effort. Your mental arithmetic questions for today are again quite wordy. True and false in question 1, and then 2, 3, 4, 5. Read the questions carefully. Make sure you understand what I'm asking you to do. Make sure you recognize whether you need to do 1 or 2 or possibly 3 different calculations, and then don't forget to check your work at the end. Right, give it a good shot. 1 was true or false, and that's just going over angles in parallel lines. Alternate angles, also called Z angles, are always equal. That's very true. Supplementary angles, also called cointerior angles, add up to 270. That, I'm afraid, is false. So we know that cointerior angles or supplementary angles need to add up to 180 degrees. And C is true, as corresponding angles are called F angles, and they are always equal. So statement B there would have been false. Question 2, find the cost of 2 adults and 2 children for the annual air show. Children are half price, adults cost 45 Rand. So adults will be 45 multiplied by 2, which gives us 90 Rand. And then the children, we need to divide 45 by 2. And that gives us 22 Rand 50. But we know that there are 2 children, so it actually is 22 Rand 50 multiplied by 2, which gives us 45. And then it's just the 90 for the adults plus the 45 for the children, and that will give us 135 Rand. Okay? For question 3, a woman is employed for 36 hours from Monday to Friday, inclusive, which means you include Monday and Friday. Find in hours and minutes the average time she works each day. So if it's 36 hours, and Monday to Friday is 5 days, then we're looking at a calculation like that, 36 divided by 5. So we can do this in short division, okay, and you will see that that works out to 7, remainder 1. Okay, so that's 7 hours, but the remainder 1 is remainder 1 over 5, and that needs to be a fifth of 60 minutes. Okay, and 60 divided by 5 is 12 minutes. So she works for 7 hours and 12 minutes. Okay, so the important thing there is to convert the remainder 1 over 5 into minutes. So that will be 1/5 of 60, which gives you the 12 minutes. Okay. Question 4. From 100 Rand, Ahmed receives 37 Rand. His 3 younger sisters shared the remainder equally. How much did each sister receive? So the first thing we need to do is find out how much the sisters need to share out amongst each other, and that's 63 Rand. We take Ahmed's amount off first, and then 63 divided by 3 is going to give me 21. So each sister gets 21 Rand. And again, if you needed to work that out, you could have done it like this. 3 goes into 6 twice and into 3 once. You could have broken up the 63 to 60 divided by 3 is 20, and 3 divided by 3 is 1. Put them together, it gives you 21. Okay, so the same answer. And then for question number 5, divide the total of 11 Rand 70 and 2 Rand 80. Okay, so we need to divide that by 5. So first we need to add it, and we can do this in a column method. You could also just add the cents together, get 1 Rand 50, add the rands together, which is 13 Rand, and put the 1 Rand 50 and the 13 together to get 14 Rand 50. And then we must divide this by 5. And it's short division, so there's no problem in doing this method. 5 doesn't go into the 1, it goes into the 14 twice, comma, in line. That leaves me with 4, so that becomes 45, and we know 5 goes into 45 9 times, and it goes into 0 times. So 14 Rand 50 divided by 5 is 2 Rand 90. And remember to check that. We can say 2 Rand 90 multiplied by 5 and check if it works out. So 290 multiplied by 5, and I'm going to say 2 times 5 is 10 Rand. The 90 cents times 5 is going to give me 4 Rand 50, and that gives me my 14 Rand 50 that I started off with. Okay, right, well done for working through that. Have a look at enlargements, and really enlargements are quite simply one shape is made bigger. So you can see that shape A1 on your screen is an enlargement of shape A. And some of the things involved with enlargements are how much larger is shape A1 than shape A. And if you counted the length of one of the sides, you'll notice that A1 is 2 times the length of each side in shape A. So quite a straightforward one to start with. So we say that shape A has been enlarged by a scale factor 2. Okay. You can also be given the lengths of the enlarged shape. So you can see A1, C1, B1, they've given you the lengths. And that's obviously the enlarged shape of ABC. And now they want to know what is the scale factor. So how much has it been enlarged by? So what we do is we take the enlarged sides. So for example, A1, B1 is the enlarged side of AB. So that would be 6 centimeters over 4 centimeters. Now that scale factor, or the scale factor that AB has been enlarged by to get to A1, B1, so from 4 centimeters to 6 centimeters, has to be the same scale factor as B1, C1, so 12 centimeters, which has been enlarged from BC, which is 8 centimeters, and that needs to be the same as A1, C1, which is the 9 centimeters, which has been enlarged from AC, which is 6 centimeters. Okay. An important thing to notice in enlargements is that the sides enlarge of the shape, but the angles remain exactly the same. Okay. So once we put all those sizes in their correct places, so for example, A1, B1 is going to be 6 centimeters over 4 centimeters. B1, C1 over BC is going to be 12 over 8, and A1, C1 over AC is going to be 9 over 6. Those are all equivalent fractions, okay? And they all work out to 1,5 or 1.5. So therefore we know that the scale factor from ABC to A1, B1, C1, the enlargement scale factor is 1.5, okay? So you might be asked to actually find the scale factor. So what is the scale factor for the following enlargement? And again, you can just count the length of a side. So if you have a look at the vertical side on the right, you can see the smaller shape is 2 squares high. And then when you go to B1, you can see that it is now 6 squares high. So to go from 2 to 6, we multiply by 3. So therefore the scale factor is 3. Okay, the same here. You calculate the length of one of the sides. You calculate the length of the enlarged shape, one of the sides of the enlarged shape. Just make sure that they are corresponding sides, meaning that are you looking at the same side on the enlarged shape as the original. And you see how much it has increased by, and you can see that that's a scale factor of 2. So each side length has been doubled. So you can also use a center of enlargement. So to define an enlargement, we must be given a scale factor and a center of enlargement. And now what that means is, if I give you a smaller shape like triangle ABC, and I say enlarge it by scale factor 2 from the center of enlargement O, then what we need to do is we need to draw a line from the center of enlargement O to each vertex. Remember, a vertex is a corner, and because it's scale factor 2, we just double that length, and that will get us to point A1. We do the same thing for B. We measure from the center of enlargement to B. We double that length to B1, and the same for C. Double that length, and that's our enlarged triangle ABC is now A1, B1, C1, and that would have been enlarged by a scale factor of 2. Okay, and then if you wanted to check, all these ratios need to be equivalent, and they would all equal 2. So OA1 over OA would be equal to OB1 over OB would be equal to OC1 over OC, and all of those would be equivalent, and all of them would equal 2, meaning the scale factor is 2, meaning the shape has been enlarged by a scale factor of 2. So here we're going to enlarge a parallelogram, ABCD, and we're going to enlarge it by a scale factor of 3. So multiplying each side length by 3. But instead of just multiplying each side length by 3 and drawing that shape in a random space, we're going to use the center of enlargement O to make the ABCD parallelogram bigger. So we just go from the center of enlargement to each vertex, measure it from O to A, and then we got to triple that length or multiply it by 3 to get to A1. We do the same to B to get to B1, same to C to get to C1, and the same to D to get to D1. Now it's a case of joining up those vertices, and you will notice that from OA to OA1 is going to be the same ratio throughout, meaning that it is a scale factor of 3. Okay, so just here's some real life examples. And here what they want to know is what is the value of the missing lengths. So you need to take corresponding sides. So what I mean by that is if you have a look at the 5.6 on the left, that is the height of the flower. That has been doubled to 11.2. So those are the two corresponding measurements. So that means that my scale factor is 2. So for 2,9 at the base, measuring that lowest leaf, I need to double that, and that will give me 5.8. And if I have a look at 13.4 on the right hand side, I'll just need to halve that to get to 6.7. Okay, so the important thing there is to make sure you work with the correct sides and that they correspond with each other. Okay, here just in a photograph, there's an enlargement. So what is the length of the missing side? So again, we need to look at the top side where it says 4 centimeters, and that increases to 10 centimeters. So what do I multiply 4 by to get to 10? And you can just divide 10 by 4 and you'll see that it's 2.5. So therefore I must multiply 3 by 2.5, and that gives me 7,5. Okay, 3 times 2 is 6, and then 3 times a half is 1,5. Put them together, you get 7,5. Okay, and then this photograph is also an enlargement. So here you just need to look at the 5 and the 12.5 centimeters. What do I do to get from 5 to 12.5 centimeters? By multiplying. And yes, you would multiply by 2.5. So what multiplied by 2.5 gives me 10, or you could just divide the 10 by 2.5 and you'll get 4 centimeters, and that's a scale factor of 2.5. Okay, sometimes they will give you a diagram on a coordinate grid. A coordinate grid is simply an X and a Y axis. Okay, you know X goes horizontally and Y goes vertically as labeled in the diagram. And here they want us to enlarge this triangle by a scale factor of 2. And they would like us to use the origin. The origin on a coordinate grid is always the point 0. Okay, 0 on the X and 0 on the Y. And that's where they want us to enlarge this shape from. So what we do is we measure lines from that point of origin to the smaller shape's vertex, and then we double it. So you can see that A goes to A apostrophe, and each coordinate point is doubled. So 2 doubled to 4, 4 doubled to 8. Remember that the X value comes first, so the horizontal value is first and the vertical value Y comes second. And you can see from the origin to point B, B is 3 and 1, and that gets doubled to 6 and 2, and C is 4 and 3, 4 on the X and 3 on the Y. And then that gets doubled to 8 and 6. Okay. So what happens when you enlarge a shape from a center of origin? Every single time, if it's a scale factor 2, you just need to double the coordinates. Okay, if it was a scale factor 3, you can just triple the coordinates, and that works when the center of enlargement is the origin. Okay, so there's a little hint there for you to remember going forward with enlargements. Okay, and that brings me to what do you notice about each point in its image? The image is the enlarged figure, and that's just what we've discussed, that each coordinate point is simply doubled. Okay, okay, good. And then there's just a second one that I thought would be worth going through. So here you can see the vertices of the triangle. So the vertices are the corners of the triangle. So A's vertices are 2 on the X and 3 on the Y, and you can see that point. B's vertex is 2 on the X and 1 on the Y, and C's vertex is 3 on the X and 3 on the Y. And what they want us to do is they want us to enlarge that triangle by a scale factor of 3 from the center of enlargement. So knowing what you know from the previous slide, with the center of enlargement at the origin, which is 0 on the x and 0 on the y. All we would need to do is multiply the point A vertex 2 and 3 by 3. So 2 times 3 is 6, 3 times 3 is 9, and that would be um, our new coordinate for the enlarged vertex of A. All right, and we'd have to do the same to C. Just multiply 3 and 3 by 3, and you get 9 and 9. And for point B, you'd multiply 2 and 1 by 3, and you'd get 6 and 3. Okay, and that's because we are enlarging from the origin. Okay. Right, let's have a look at some more examples of drawing enlargements. Drawing enlargements, and you can see how they've given us a point of origin, and it's just a recap of how you would measure from that yellow point of origin to the original vertices of the smaller shape, and then double it according to, or triple it according to the scale factor to create the new coordinates or new vertices of the enlarged image. Okay, so here they want us to start with a point and a shape. So there they've given us the point in yellow and the yellow triangle. Draw lines to each point on the shape like that. They want us to increase it by scale factor 2. So we double each length, and then we get to a new image, and you'll see the outline of the image, and that is our enlarged shape. Okay, so this is just a different way to show you how to draw it, and again they want us to enlarge by a scale factor of 3. So I must multiply all those lengths that I've drawn on the image at the moment by 3. Okay, and that will give you the enlarged image, which you can now see is drawn in. So here we work in a different direction. So just to show you that the center of enlargement can pretty much be wherever they want to put it. Okay, and again, same principles apply. You draw a line to each vertex, you measure it, you find out what they want you to increase it by or what the scale factor is, because most of the time they'll tell you. So you multiply each length by 2, and the important thing to notice here is that the image can actually overlap the original image. Okay, so don't be concerned if your enlarged image is overlapping your original small image. If that's the way it works out, then that's the way it works out. Okay, so here they want you to enlarge the shape by a scale factor of 2, and notice here that we are not enlarging from the origin. So the center of enlargement has changed to 1 on the x and 2 on the y. And let's see how this differs. So here we would need to measure, okay, and they want us to increase by a scale factor of 2. So we'd have to measure each length and double it, and then that would give you your new image. Okay, so it's a bit different to when we're enlarging from the center of the origin. So 0, 0. Remember, we could just double the values of the original coordinates. Here, when it's at 1, 2, we'd have to measure and double. Okay, and here's another example for you, enlarging from a completely different point. And again, you'd have to draw lines to each vertex, double it, okay, or multiply by 2 to get your new vertices, and then you can join up those new vertices, and that would be your enlarged image. Okay, so just notice the difference between enlarging from the center of origin, which is 0, 0, where we just doubled or tripled or multiplied the original coordinates by whatever the scale factor was. Here we're actually drawing lines and then doubling or tripling them depending on what the scale factor is. Remember, the scale factor can be anything. They can ask you to enlarge by a scale factor of 10, 20, 30. You'd obviously need to have a really big piece of paper, but yeah, there's no limit to the scale factor. Okay, so here we're going to work backwards. So here perhaps they give you both images, the smaller and enlarged image, and now they want you to find the center of enlargement. So you're quite correct in saying that we would simply just work backwards. Okay, so now if I ask you to find the center of enlargement, they give us the shape, they give us the image, and now it's just a case of drawing lines backwards to find the center of enlargement. Okay, so from each vertex of the enlarged image, you draw backwards and make sure that they connect through the vertices of the original image, and you'll see that all three lines end up at a point, and that would be your center of enlargement. And your scale factor you'd be able to work out by measuring the lines, and that would be a scale factor of 2. Okay, and then another example, the shape and the image are given to you. You need to find the center of enlargement and the scale factor. So again, you can draw lines from the enlarged image through the vertices of the original image, which is happening right there. And you would find the center of enlargement would be 1 on the x and 0 on the y. X comes first, y second. And if you measured those lines, you would notice that they had been multiplied by 3. So therefore the scale factor is 3. Okay guys, that's enlargements. So scale factor, how much do I multiply the side length by to get the new side length? We spoke about the center of enlargement. So where could you enlarge a shape from? Where we would draw lines from the center of enlargement through the vertices of the original shape, and then measure the lines and then multiply them according to the scale factor. And then we also looked at enlargements on a coordinate grid. And we spoke about the difference between the center of enlargement being the origin, so 0 on the x, 0 on the y, compared to other centers of enlargement. And then we worked backwards where we gave you the original image and its enlarged shape, and then we asked you what was the scale factor and where was the center of enlargement. So if this is a new concept to you, feel free to go back and have another look at it. I've set you an online activity with a memo. So there are a couple of examples there for you to work through to consolidate this principle or these ideas. And please, guys, email me at the email address that you can see on the screen, grade7@worksheetcloud.com, and I'd be happy to explain it further to you if that is required. Your finisher for today is the game of 24. And I'm sure you now know that you need to use all 4 numbers and either all the operational signs or 1 or 2 or 3 or however many you want to get the answer of 24. And remember to try and see if there's more than one way to get the answer of 24. Okay, grade 7s, thanks very much for tuning in to Worksheet Cloud. Yeah, have a really good day, and I'll catch up with you guys tomorrow. All the best.